good afternoon, welcome to Maths Live. I already got some shout outs. Say hi, Harry in Nottingham, Sam in Nottingham. We've got Elliot, Maxwell, you're joining in. Here's your starter challenge for the day. So it says, what are the missing values in each sequence? So we've got A is 13 something 25 something 40, and then B is 1 2 something 16 25 36. Use the same method as yesterday. Think, which numbers have I got, which numbers have I haven't. I want to compare them, see how I can work out the missing number. Okay, I'll give you about a minute to go on that, and then we'll have a look. Okay, we've got hi Jacob in Stockton, hi Hallie Bear, hi Emily in Chorley, hi Namira in Norwich, hi Noah in Broughton. I'll wait to see some answers coming in. Hi Lachlan in Royal Leamington Spa. Anyone got any answers for the first sequence? Second sequence is quite tricky. Hi Maya in Sunderland. Oh, we've got one answer coming in. Hello Heidi in Broughton as well. Hi Kim in Norwich. Oh, no answers yet though. Wakey wakey guys. Unless I made it a bit too tricky to start. Oh, Harry's got an answer in. Oh, is it tricky? Okay. Okay, alright. Don't worry if it's a bit too hard. I just wanted to give you a bit of time. Been a bit mean to start. Okay, so with this one, have a look at what the jumps are. So you've got 13, so 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So to go from there, you've added 12. Okay? And then to go to 25, so 26, 27, 28, 29, 30, you've added 15. Okay? So if you've added 12 that way, it must be that you've added, can you add 6 in one bit? And then add 6 in the other, does that work? So if it's going up 12, 15, okay, it will be going up and then 18 and then 21 and then 24, because you can see the gaps, the jumps. Okay, so if it's adding, so if it's 12 there and it's 15 there, it's plus the extras 3 each time. Okay, sorry, that might be a little bit tricky if that's a bit mean. So if it be 12 here, it will be, so that will be 19, and then plus the next lot will be 25. Okay, sorry if that's a bit tricky. Been a bit mean there. The next one, I'll give you a clue. 1 is 1, just made a mistake, that's why. I just realised. Oh, Steph's made a mistake. Let's just see, has anyone noticed? So, what if I change that? Steph made a mistake. I put the number that's starting from, and I forgot to add something on. So it's 1, 4, something, 16, 25, 36. 1, 1 is 1. Something, something, 4. Gap. Something times something is 16. Something times something is 25. Okay. Oh, here we go. Got some answers. I've got one answer. Yay! Yeah, we've got 2 people there. It's square numbers. It's going up in square numbers. So 1 times 1 is 1. Sorry, I meant 2 times 2. I just got excited and put 2. So this is 4 times 4, 5 times 5, 6 times 6. So the middle one will be 3 times 3, which is 9. I wasn't going to give you ones just like yesterday. That's too easy. But, sorry, it's definitely a bit too far today. Bit too far with that starter challenge, but I'll be nicer during the lesson. Okay, so today, we're still on number sequences, but we're going to try and explain number sequences using formulae, okay? The main thing I want to go through first is that word terms. T-E-R-M-S. Terms is basically how many numbers are in the sequence. So if we have 1, 2, 3, 4, 5, nice easy sequence. So all we're doing is we're adding 1, aren't we? But that doesn't matter, because each of these numbers are terms in the sequence. This is the first term, this is the second term, third term, fourth term, fifth term. Show you another example. It could be 2, 4, 6, 8, 10. So this is the first term, this is the second term, this is the third term, this is the fourth term. It's basically how many numbers there are in a sequence, and you scribe each term. So the number in the third term is 6. The number in the fifth term is 10. All it means is a particular number in the sequence. Now, we're going to be using something called the nth term. The nth term. And all that means, like we do in algebra, is when we have an unknown, when we don't know a number or we don't need to know a number yet, we replace it with a letter. You can, we don't normally say the xth term, that's quite hard to say, we say the nth term. So it might be, we don't know which part of the sequence it is yet, so don't worry about too much of that. It might end up being that the question is the 10th term. It's just there, ready to be used. So let me give you a sequence. And it's quite good actually, because there's no missing gaps this time. You're not having to find the missing gaps, you're just having to describe the sequence. So let me show you, okay? So 7, 13, 19, 25, 31. So this lesson is not about trying to find the missing gaps, it's just describing the sequence. And when you're able to describe the sequence or find a rule, you can find any term in that sequence. So we've got 1, 2, 3, 4, 5. There's 5 terms in this sequence, 5 numbers, great. Now we've got to work out the rule. So if I put that that's the first one, second, third, fourth, fifth. Let's find out the rule. So let's check. What did we do 7 to make 13? So 7, 8, 9, 10, 11, 12, 13. We added 6. Let's check it. Do we add 6 each time? 13 to 19. Oh yeah, add 6. Okay. So the rule is add 6. But you might get asked, what is the 12th? What is the 12th term? That could be a question. You think, oh, what? So am I going to have to write the 6th and the 7th and the 8th and the 9th and the 10th and the 11th and the 12th? This is where you don't have to, okay? Because you find out what the formula rule is for the sequence, and then you can apply it to any number. So, the rule is, so if you look, so it's n plus 6. So each number, you're on that nth term plus 6. So if we're on 1 and we add the 6, it goes to 7. So actually 1 plus 6 is not 7, it's not 6, it's 7. So to get from 1 to 7, we've added 6 and we've got to times it by 6, because 1 6 is 6, and then add 1. So to get from the first term to 7, we've times 1 by 6 and then added 1. Does that work with every single number? Can I times any of those terms by 6 and add 1 to get the answer? Let's take the third term. So if I change that n to 3 and I times it by 6, 6 3s are 18, and if I add the 1, that makes 19. What if I change n to the 5th term? Okay, so if I do 5 times 6, which is 30, and then I add the 1, that's 31. Okay, so the formula to make this sequence work is n times 6 plus 1, or you can do 6n plus 1. It means exactly the same thing. So if we ask for what the 12th term is, all we've got to do is replace n with 12. 12 times 6, which is 72, plus 1 is 73. So we don't have to go up to the 6th and the 7th and the 8th and the 9th and the 10th and the 11th. We can jump straight there. Don't worry if you're panicking. Don't worry if you don't get it. I'm going to explain it again, and then I'll explain it again. If you want to have a go while we're joining in, you can do. Okay, this is not only year 6, this is creeping into year 7. Okay, you'll be definitely doing this in secondary school. So if you're watching in year 3, year 4, if you just want to watch, that's absolutely fine. I'll give you another sequence. So 9, 18, 27, 36. Oh, I bet some of you are saying, I know what it is. There's the first term, second term, third term. Just got 4 terms in this one. Okay. Now, what's the jump? Always find out the jump first. It's easy, this one. 9, 18, 27, 36. We're just adding 9 each time. So, let's find the rule. So what do you do to each term to make it into the answer? So, and we always have to look at what we're adding first. So, is n times by 9 the answer? Oh look, 1 times 9 is 9. Let's try replacing n with 2. 2 times 9 is 18. 4 times 9 is 36. So the rule for this one's really easy. It's just 9n. That's the rule for the sequence. So if you're asked for the 13th term in the sequence, you just do 13 times by 9. Yeah? So they're not always n times something plus something. Sometimes they might be n times something, take away something. Okay, I'll give you another one. 5, 8, 11, 14, 17. Okay? Right, first of all we find out the jumps. So 5, 6, 7, 8. 8, 9, 10, 11. Right, we're adding 3 each time. Here's the first term, second term, third term, fourth term, fifth term. By the way, you don't have to write the numbers above, okay? I'm just doing it to demonstrate, okay? So, we're adding each time, so it's n times 3, or n3, or 3n, I should say. Now, so let's test it. 1 times 3 is 3, but we need to get to 5. So what if we add the 2? Does that work? 2 times 3 is 6, plus 2 is 8. Right, let's replace n with 5. 5 times 3 is 15, plus the 2 is 17. So the rule for this sequence is n times 3 plus 2, or 3n plus 2. So if you were asked to find the 15th term in this sequence, you would just do 3 times 15 plus 2, and you'll get your answer. Okay? Right. Let's go to the challenge question. I'm going to have to do a bit of drawing again, and I'll give you a bit of time to have a go. So you were given a sequence. The sequence was 13, 17, 21, 25, and 29. And they were really nice to you in the question because they gave you the formula. They said the formula is 4n plus 9. Okay, they gave it to you. We know that's correct because if we do, there's the first term. So if we do 1 times 4 is 4, and then we add the 9, that makes 13. And you were given a table. And you put the term there. So you were given 4 terms to do. I'll add another one in there. Okay. So you've been asked to find the first term, the 5th term, the 20th term, okay, and the 100th term. Okay? And it tells you how to do it. So if you're finding the first term of this sequence using this formula, you would put, so the first term is 4 times 1, because it's the first term, plus 9, and we know the answer is 13. Okay? That's the part it gave you. It told us, jumping right down, if you want to find the 100th term, you just replace n with 100. So it would be 4 times 100 plus 9. And it told us the answer to this one was 89. So can you try and work out what these missing values are? I'll give you a couple of minutes to have a go, 2 or 3 minutes, but I'll just have a look at some comments. Oh, that's good. It's nice that some of you are saying, oh, that's actually alright. I'm just going to scroll back. Oh, there's loads of comments. Wow. Oh, guys, you are amazing. You guys are so good, because I can only imagine that when I'm doing this, you just sort of sat watching and thinking, okay, I do get it, but I go and look, and you're joining in, you're throwing answers out there, and that's really nice that you've got your sort of commentating with me. I can't see that. I wish I had a screen, or like with Joe Wicks when they say in your ear. So it's really nice to go back and you're giving it a go, which is amazing. It is hard. Hi, Harnett and Coventry. Sorry, I might have missed some shout outs. Oh, this makes much more sense now, thanks. It does take a little bit of... Hi, Ethan. Right, got some answers. So... Okay, just having a look. Good. Yeah, so in this part, you only have to write the calculation. In this part, you need to calculate the answer. So if we're looking for the fifth term, we're replacing n with 5. So we're doing 4 times 5 plus 9. So 4 5s are 20 plus 9 is 29. Okay? The 20th term, we've been given the answer, we don't need to do the calculating. All we need to do is replace n with 20. So 4 times 20 plus 9. Okay? And then the last one, 4 times 100, we know is 400 plus 9 is 409. Good. Well done. Right. Your turn now. I'm so impressed this week. You've been really, really great, especially when that first lesson on Monday I really didn't like. I thought I did a bit of a rubbish job, so for you guys to keep up and be doing this is amazing. Right, challenge now. So I'm going to give you some number sequences, and I'd like you to try and work out the formula to describe the number sequence. So remember, if I write the numbers, work out the gap, whatever the gap is the number you're timesing by, and check to see if you need to add and subtract anything on. So, here you go. 8, so 16, 24, and 32. That's your first one. And your second one is 12, 22, 32, 42. So can you find the formula for each sequence? Give those two a go. Brilliant, well done. Fantastic. Hi Ellie in Barwell. Hi Isaac in Essex. Hi Daisy in Wales. Hi Isaac in Colchester. Super. So remember to look at the jumps, find the jumps first, and then relate the jumps to the term. Right, Lachlan's got 1. So I can see some of you are putting, right, I know how the jumps, but try and put it as a formula. I want the letter N in there. See if you can write the formula that includes the letter N. So it's not just add something, it's got to have the letter N in. Okay, I'll jump in and I'll explain it, and then you can give it a go in the next one. So, we've got first term, second term, third term, fourth term, fifth term. So, you've noticed that it's add 8 each time. 8 times tables. So, it's 8n or 8 times n. Okay, check it. So 1 times 8 is 8. 8 times 2 is 16. So the formula simply is 8n. That's the formula. You don't have to add any adding or subtracting on top of that. It's just 8n. With this one, we're adding 10 each time. So the formula, the formula is n10 or 10n, doesn't matter which way, I'm going to put 10n because it sounds a bit better. 10 times n, so there's the first term, second term, third term, fourth term. So if we use the first term, if we replace n with 1, 1 times 10 is 10, but we want 12. We need to add 2 more to make it into 12. Let's check with the second term. If we replace n with 2, It's 2 times 10 is 20, but again we're too short. So the formula is 10n plus 2. So let's take the fourth term. If we replace n with 4, that is 10 times 4, which is 40, plus 2, 42. So you're looking to have the n in there and check if there's anything you need to add and subtract. Okay, so you're identifying the jumps. It's just remembering to put it into that formula. Let's try another one. I'll give you one this time and then we'll go on. So 10, 13, 16, 19. Can you have a formula that's got n in it? So it's something n, and I don't know if you need to do anything else. Have a go. No, question of Katie, it does not have to be in capital letters. Formulas do not have to use capital letters. Good question. You can see my n is a little n. Okay. Okay, it's 3n. Do you need to add anything or subtract anything? So you said it's 3n. So if I replace n with 1, 3 times 1 is 3. So is my first number 3? I've spotted one person's got it. Just check, because if this is the first term and I replace n with 1, okay, you recognise that it's at 3. So if it's 3n, is 1 times 3, that's 3, but we don't want 3 in the first term, we want 10. So we do need to add something. What do we need to add? Check. Keep replacing terms. So try it. Put the fourth term in. Is 3 times 4 19? So if we put the first term in, so if we do 3 times 1, that's 3. To get 10, we need to add 7. Let's check it with the third term. So if we replace n with 3, that'll be 3 times 3, which is 9, but we need to get up to 16. It's 9, 10, 11, 12, 13, 14, 15, 16. So the formula is 3n plus 7. Okay. Let's try another one. So 3, 8, 13, 18. That's a two-part question. I'd like the formula, so something, and it could be add or subtract something. And I'd also like the 11th term of the sequence, please. So what is the 11th term? So this is the first term, second term, third term, fourth term. So I want you to find the formula and then use that to find the 11th term. Right, I can see that Harry has got the difference. Harry's got the rule. So we have got that number, Harry. Okay, a lot of you are putting 5n, but you've got to be careful. Because yes, the jump is 5, so we add 5 each time. But if it's 5n, 1 times 5, it's not 5, is it? If we do 4 times 5, it's not 20. So think, what do we do? There's something missing here. There needs to be something on there. I'm just reading your answers. I'm just going to move this down here. So 5n, and there is something missing. So let's test it. So if I move this out of the way. So 5n, so if you do 5 times 1, that's 5. If you do 5 times 2, that's 10. If you do the 5 times 3, that's 15. So these are the numbers that 5n is giving us, but these are the answers, these are the numbers we want. So what do we do to 5 to make it into 3? What do we do to 10 to make it into 8? What do we do to 15 to make it into 13? We need to subtract 2. So the rule is 5n, take away 2. So 5 times 1 is 5, take away 2 is 3. 5 times 3 is 15, take away 1 is 13. So if we put in the 11th term, that will be 5 times 11, which is 55, take away 2, which is 53. Okay? So I know you're doing really well to tag along, because like I say, this is definitely going into year 7. Got one more question. Just one more try. Okay? I'll try and take my time, explain it. I'll try and add in any more drawings that I can do to help. So we've got first term, second term, third term, fourth term. I think we're on the, 1, 2, 3, that's it. So it's 7, 10, 13, and 16. Okay, so think first of all, what's the jump? Okay, then put that into n, and then check. So would 1 times that jump make 7? Good, well done. Good, good, good. Doing really well here, guys. I know it's tricky. Okay, right. So we've got a lot of you saying what the jump is. Oh, someone's had a go at the full formula. Well done. Hi, Noah. Oh, someone else has had a go at the formula. Someone else has had a go at the formula. Oh, all these formulas are coming in now. Aha! I think we've cracked it. So yes, you add 3 each time. Okay, so we know that now. We're adding 3. So it's 3n. Okay, but we need to check each of the values. So if we do 1 times 3, because it's the first term when we times, if we replace n with 1, that's 3. If we replace the n with 2, so 3 times 2, 2 times 3 is 6. 3 times 3 is 9. So what's happening? So we're at 3, we need to get 7. 3, 4, 5, 6, 7. So we've added 4. We're at 6, we need to get 10. 6, 7, 8, 9, 10. Oh, we've added 4 again. Let's check it. 9, 10, 11, 12, 13. So it's 3n plus 4. If you've put n times 3 plus 4, that's absolutely fine. Okay, that's absolutely fine. Well done, guys. Like I say, if yesterday's lesson was the really big learning curve with number sequences and finding out the gaps, this is taking it a step further, so it's really, really good. Well done. As a super duper, I can't even go red hot, it's even hotter than red hot challenge, and I've told Maya this. If Maya's watching, she knows about this. The challenges I'm going to put up now are from a foundation GCSE paper. You heard that? They're from a GCSE paper. So you can have a look, you can give it a go, and even if you're not sure, you can just say, oh, I've tried a GCSE question. I've not done it on purpose to make it super hard. It's just that this is at the level that I found the question at. I'm not going to look in a year 6 book. I'm not going to look in a year 5 book for this. I have to go up to secondary school to find a question to challenge this. Remember, to challenge is always going to go a little bit harder than this, but give it a go. I know a lot of you give them a go, and your parents send me the question saying, did they get them right? Absolutely fine. I love checking your work. I love seeing your methods, your attempts. It's brilliant. No lesson tomorrow, so don't log in at 1:30 and expect me to be here. It's bank holiday, so I'm going to be having a rest with my husband and my little girl. Though the lesson plans for next week will go up. I will see you on Monday. Have a lovely bank holiday weekend. Thank you so much for this week.